Traveling horizontal that fast enters a uniform vertical 1 Tesla magnetic field. What's the diameter of the path followed by the alpha particle? Okay, so it's just like the last one. We're just going to set the centripetal force equal to the magnetic force. So, and we're looking for diameter. So, going back over here. So we got mv squared over r is q b v. We're trying to get r, so r would be mv over qb. Right? Okay, it's an alpha particle, so that's the mass of a neutron and proton are basically the same. So we're going to have 4 times the mass of a proton. The q, well, the q of the particle, 2 of them are protons, so that's all the charge. So you're going to have 1.6 times 10 to the minus 19. And my pen is, there we go, to the minus 19. The B, I think they said was 1. And the V was what? Yeah, that was 1. 35.6. Oh, it actually told you the mass of, let's use that mass. 6.44, 10 to the minus 27. 35.6. And I already forgot. 35.6. My pen quit working again. There we go. 35.6, and this is thousands, so yeah, because it was kilometer per second. All right, so let's grab our little calculator. 6.44 times 356,000 divided by 2 divided by 1.6 divided by 1 is that. And that's, we also got 10 to the negative 8. This is 10 to the 4th. So altogether you'll have 7.16 times 10 to the minus 4th. So get my pen to quit, start writing again. Okay, well, maybe my pen will start later. But anyway, so this is times 10 to the minus 4th, and that's the radius, right? So I want the diameter, so I'm going to go times 2. So that times 10 to the minus 4th would be 1.43 millimeters. Wait, no, sorry. I lost my train of thought. Anyway, if I got my decimal place in the right spot, it should be 1.43 millimeters. Oh, and then your jerk of a teacher had you talk about what effect does the magnetic field have on the speed of the particle? What effect does it have on the speed of the particle? None whatsoever. Just goes in a circle at constant speed. Yes, I'm satisfied with that answer. And then I'll have to go back and grade myself at some point. All right. What's the magnitude of the acceleration of the alpha particle? So first of all, let me just ask you, hey, we just said the speed doesn't change in the last part, right? Doesn't that mean the acceleration is 0? So? Think so? No, it's not 0. So the speed isn't changing. It still has a speed, but that's not the, I mean, the thing is, even though the speed isn't changing, the velocity is changing. So remember, velocity is a vector. So even though it's not changing speed, it is changing direction. If it's changing direction, that means you have an acceleration, right? Going back to this guy right here, I mean, what is centripetal acceleration? This is v squared over r. So the centripetal acceleration, or sometimes you call this the radial acceleration, is v squared over r. Right? So v they gave us, we just got r in the last part. So just go back. Well, let me pull up the problem because I don't remember v. V was 35,600, so 35,600 squared divided by the radius, which that was the point, what was it? I didn't write it down. Well, the diameter was 1.43. Okay. So 0.0007 what? 16? Okay. So that's 10 to the 12th. I'm counting right. 1.77 times 10 to the 12th. Let's try it. Wow. All right. What's the direction of the acceleration? Well, when you have something moving in a circle, the acceleration is always towards the center of the circle. Because that's, and we kind of covered that when we did circular motion last semester. It's like what keeps it going in a circle is there's something pulling it towards the center to keep it. Because I mean, if you let go of the rope or whatever that you're swinging around, then it would just fly in a straight line, tangent to the circle. But that rope is pulling it straight towards the center, so that's why it doesn't fly away. So direction of the acceleration for circular motion at constant speed is always towards the center of the circle. And then, man, I didn't realize it had so many word explanations. So, all right, explain why the speed of the particle does not change even though an unbalanced force acts on it. Non-zero force means that the velocity, let me put that in all caps, must change. But in this case, it is only the direction of velocity, not the magnitude. That is speed. Okay. Cool. Well, the next one had 6 parts, so let's look at it too, just for the grams of it. And then we'll go down and hit that 5 one. Okay. The straight vertical wire carries a current of 1.35 amperes downward in a region between the poles of a large electromagnet, where the field strength is equal to that. What's the direction of magnetic force on that section of the wire if the magnetic field direction is toward the east? Okay, so far, all we've talked about as far as what does magnetic fields do is we've talked about what does it do to a moving charge. First of all, if you have a stationary charge, magnetic field doesn't do anything because there's that velocity in the formula. But see if my pen will start writing. Whee. I don't know, maybe if I minimize it and pull it back up. That did nothing. Come on. Well, in the meantime, let's start a new video.